Welcome back to last part of lecture 6, and in this part we will do some hands-on with R. And let me just try to share my desktop. So this is this is the code that I already have shared with you in the lecture material part, that we are using Chennai 1990. We have done some work with the this data set, and in this data set what we have done is we tried to fit simple sine cosine kind of some regression model with sine cosine Fourier term or engineered term. So let us start with this. We have this data set. Let me just first clean the environment, that will help you. So this is the data set that we have. You have seen this before last week. Now the structure of the data set is everything is numeric, but time was taken as characters, so we convert it into time, and now you have this as a date format. Then now we plot this. Now N is the data set. We have 11,894 data points. Let me increase the font size a bit. Go to tools, go to global options, then appearance, editor, maybe zoom to 100% and apply, and OK. Right, and then what we are doing, we are creating another data set, another column. So there is a time, average temperature, minimum temperature, maximum temperature, and precipitation, right? And now I am creating a new column, omega. Okay. Now after creating column, you can see that what we have done, I have subtract the average time, just location, I just shift the location, and then I split the data into train and test. So any data before 31st December 2015, I have used it as train data, and if you just put a tail, so you can see the last value is of the train data is 31st December 2015, and any data before after 31st December 2015 is test data. So I am just plotting the first few rows. So from 1st January 2016 we are going to use it as test data. So then we fit first model. Okay, and this is the first model that we fitted. You can see with one that we did last week, this model we fitted last week. Then we took the fitted model, fitted values, and plot the fitted values through the average temperature. Then we fit the second model. Okay, and what we are seeing that second model with sine 2 omega t plus cos 2 omega t, they are all significant, and again we just fit the model, Then so this is sort of a, let me just zoom out. So this is, you can see every year we have some kind of sine cosine behavior. This is kind of expected, but at the same time it is kind of going up. We can see there is an increasing trend. Model is picking up a increasing trend, and we just plotted the first 10 years from 1990 to 2000, and so here is the first 10 years average expected behavior. And then if we have a 95% confidence band as well. Okay, now, and this is the from 2000 to 2010. Okay, now we are going to add, why we are only going to stop at 2 omega and cos 2 omega. We can add as many cases as we want, say maybe up to 7 omega or 8 omega. Okay. 4. I'm adding as many engineered features as possible, and I'm not worried about overfitting much because I have too many data, almost 11,000 data points I have, so I'm not worried. Okay. So let me just try 7 Fourier terms. Let us see. And we can see that there are some Fourier terms like cos 5 omega is not significant. Actually, in fact, after 3 omega onwards, the significance has dropped to an extent, though sin 6 omega does have an effect, but cos 6 omega, 7 omega, they don't have an effect. You can even try a few more if you want. You never know if in case there are some higher things. 9. So this is, yeah, so yeah, from 5, 6, 7, 8 may have, but 9, 8, 9, they don't have much effect. So what we will do, we don't want to keep growing the model size. Okay, and if we do that, we will see that there might be eventually overfitting is happening. So what we will do, we will keep this model, and at the same time we will fit another model called model 4, and we will apply stepwise variable selection on the model 3. So if we just, you see, it just fitted these models. So these models were fitted. Okay. So yeah, here from here. So this is the model that was fitted with this AIC, and then this is the model that was fitted, and eventually it settled down to a model. And let's see what was that. So I can just copy and paste it here and take some summary 4. So it has dropped the cost terms and kept only the sign terms that has effect in the model, though it did not throw away the cos 9. So we can actually, that means we can add few more terms. And let me try this. And so yeah, looks like, and then let me just run this stepwise forward selection. You can see it just ran, and let me just run it. So now it has completely dropped the 11th Fourier term, and it stopped at 10th Fourier term. So we can just stop at here. So we can just, and now what we will do, we will do the prediction. So first we will do prediction, and we will calculate the out of the sample accuracy. So in the test we are creating prediction, and here is the out of the sample accuracy. And then we will do, so what was the RMSE? So 1.50 for first model. Then if we do prediction for the second model, and RMSE would be 1.37. Now if we do the same thing for the third model, let us run that, and the RMSE 3 is 1.38. Now you can see that RMSE has gone up because we have added too many models, so that we can see too many Fourier term, too many engineered term, and as a result you can see that there are some overfitting tendencies being picked up. And then we have the stepwise selected for selected model. So from there, if we calculate the RMSE, out of the sample RMSE is 1.379. So this is where it is stopping. So either we can go for fourth model, or we can go for, because end of the day the simpler 1.378, the simpler second model with two sine cosine Fourier transform has a lower RMSE than a bigger, more complex model, even if after doing a stepwise selection. So if I have to choose out of these three, I will go for the second model. So if I have to, let me just, let me just RMSE equal to RMSE 2, RMSE 3 equal to RMSE 3, and RMSE 4 equal to C4. Okay. So clearly, if I just say RMSE, is this, and which dot mean of RMSE. Clearly the second one is the RMSE M2. The second model has the maximum minimum RMSE. So even if after doing the stepwise selection, significant dimension reduction, the model is still complex and doing some bit of overfitting perhaps. So we can do summary of mod 2. So we can look into the parsimonious model. This is our parsimonious model, and perhaps we just be happy with this. And we just take this line and run once more, and with this we run this. And sigma, we need the sigma of this, correct sigma for this model. We have to just go up. So now if we just look into this, so this is our final out of the sample performance from 2016 to 2022. Now here is one self-assessed assignment for you guys. Use this model and can you find what would be the temperature of Chennai, average expected temperature of Chennai in January in year 2033, that is 10 years from today, in January, say 30th January, what would be the expected temperature? Can you, with this kind of confidence interval, can you figure that out? And if what is the expected temperature in the 30th January on 2023 and how much increase you are observing? Can you do this self-assessed exercise and let me know that what is your findings? That will be really fun exercise, and I think that will be, we all want to know that, the answer to that question. Thank you very much. See you in the next lecture. Bye.